The parity operators. The parity operator is a mathematical operator denoted by pi k. For a function of variable x, it has a relation pi k psi function of x is equal to psi minus of x. Operating on wave function psi 1 and psi 2 with pi cap operator, we get pi cap bracket psi 1x plus psi 2x bracket close is equal to psi 1 minus of x plus psi 2 minus of x, that is pi cap psi 1x plus pi cap psi 2x, and pi cap bracket c pi function of x is equal to c pi minus of x is equal to c pi cap psi x. For every function psi and pi cap operator is a linear operator. First, pi cap operator is Hermitian. The scalar product of pi psi and phi function is given by scalar product of pi cap psi and phi is equal to integration minus infinity to infinity psi star minus of x because of parity operator and phi function of x dx is equal to minus infinity to infinity psi star x dash phi minus of x dash dx dash, where x dash is equal to minus of x. Since the value of integer is unaffected by renaming the variable of integration. We get pi cap psi phi scalar product is equal to integration minus infinity to infinity psi star function of x pi minus of x dx is equal to psi pi cap pi scalar product. Pi cap apply on phi x, so phi of minus x. The relation shows that pi cap is also Hermitian operator. The second is eigen value of pi cap operator. The eigen value of pi cap is given by relation pi cap function psi is equal to lambda is eigenvalue function psi. Here lambda is eigenvalue of parity operator in state psi. Operating again by pi cap operator, we obtain pi cap whole square psi is equal to pi cap lambda psi is equal to lambda pi cap psi is equal to lambda square psi. Equation 1. Also from definition of parity operator, pi cap psi function of x is equal to psi function of minus x, pi cap whole square psi function of x is equal to pi cap bracket pi cap psi function of x is equal to pi cap psi function of minus x, that is pi cap square psi function of x is equal to psi function of x. Question 2. Comparing equation 1 and 2, we note that the eigen values of pi cap operators satisfy the equation lambda square is equal to 1. That means lambda is equal to plus minus 1. The eigen function corresponding to the eigenvalue lambda is equal to plus 1 of the parity operator are even functions psi e and satisfy even function is equal to psi minus of x. The odd eigen function psi o corresponds to the eigenvalue lambda is equal to minus of 1 and satisfies the relation psi o minus x is equal to minus of psi o minus of x, so that psi function of x is linear combination of even function psi x plus psi minus of x and an odd function of x psi x minus psi minus of x, that is psi x is equal to half psi x plus psi minus of x bracket close plus half psi x minus psi minus of x. Now the third point is commutation relation with Hamiltonian of a system. The Hamiltonian operator is h cap is equal to p square by 2m plus v function of x. If it is operated on a function psi x so that h cap psi x is equal to minus h cut square by 2m d2 by dx square function psi x plus vx function psi x. Now operating pi cap operator, h cap psi x is equal to minus h cut square by 2m constant pi cap d2 by dx square psi x plus pi cap vx psi x, which is minus h cut square by 2m d2 by dx square pi cap apply on psi x will be equal to psi of minus x plus pi cap apply on vx and psi x. This is v minus of x psi minus of x because pi cap psi x is equal to psi minus of x, pi cap vx is equal to v minus of x, which is equal to vx also. Now minus h cut square by 2m d2 psi minus of x by dx square plus vx psi minus of x. Psi minus of x is would be common, so minus h cut square by 2m d2 by dx square plus vx psi minus of x is equal to h cap pi cap psi function of x, that is pi cap h cap, which is this minus h cap pi cap psi x, which is common, is equal to 0 as psi x is not equal to 0. Therefore h cap pi cap minus pi cap h cap is equal to h cap pi cap commutator is equal to 0. This equation shows that the parity operator commutes with the Hamiltonian. Now the next topic is projection operator. Consider A and B are complementary subspace. Any eigen vector possesses a projection in capital A and small b projection in B subspace. Let these component vectors be denotes by psi A and psi B respectively. These are these vectors are uniquely defined and we may write psi is equal to psi A plus psi B. Now the operator PA cap is the projection operator which brings out the projection of psi in subspace A, that is PA cap psi is equal to psi A. Question 1 also PA cap square psi is equal to PA cap psi is equal to PA cap psi A is equal to psi A. Question 2 comparing equation 1 and 2 we get PA cap square is equal to PA cap. Equation 3, that is the projection operator PA cap is idempotent now. Consider a set of basis vector psi 1, psi 2, psi 3 and so on, and for ith for projection on ith direction we get pi cap is psi is equal to ai psi I. This is eigen value equation. So pi cap pj cap psi is equal to pi cap aj psi j is equal to aj pi cap psi j is equal to aj multiply 0, which is equal to 0. Third, the projection operator on basis vector have the property that pi cap pj cap is equal to pj cap pi cap is equal to 0 if I is not equal to j. For every psi summation p lambda cap psi lambda is equal to 1 to small n is equal to summation a lambda psi lambda lambda is equal to 1 to small n is equal to psi by expansion theorem. Hence summation p lambda cap lambda is equal to 1 to small n is equal to 1. This is equation number 3. This is equation number 4. Now this is equation 5. Thanks for watching the video.